Hurricane Ida was one of the most powerful hurricanes to ever strike Louisiana, and it has wreaked havoc on the East Coast as well. Was it the result of global warming? And how do we explain changing weather patterns here in Oklahoma? Are they temporary or are they permanent? In this week's in-depth discussion, we present part 2 of our conversation with Oklahoma climate experts. Here's moderator Susan Cadell.
Thank you, Rich. Right now, everyone may be complaining because it's so hot, but actually the weather has been a little different in Oklahoma and in other parts of the country. I'd like to introduce our guest to our viewers today. First, we have Dr. Harold Brooks. He's the senior research scientist at the National Severe Storms Lab in Norman, Oklahoma. And then we have Gary McManus, who is a state climatologist at the Oklahoma Climatological Survey, also in Norman. Gentlemen, thank you so much for being with us.
You're welcome.
Thanks for having us.
You know, the hurricanes are happening more frequently. Grand weather events seem to be happening more often. Is that true, or does it just seem that way globally?
Globally, some of these things are easy to see and some aren't. The question of hurricanes is actually still not really well understood. It doesn't appear that there's been much of a change in the overall frequency of tropical weather systems, but the strongest ones, we're getting enough evidence to say that the strongest ones are getting stronger, and more of them are intensifying rapidly, and rapid intensification has a lot of issues for response, because if a hurricane intensifies, Michael a couple of years ago intensified very rapidly just before it made landfall, and so it was a relatively, even all hurricanes are big events, but it was a relatively minor hurricane until just before it came on shore. And then the winds rapidly increase. And now, it might have been the thing if, someone might say, yeah, I can handle that level of wind. Well, 48 hours later, it was a whole different beast. We are seeing, there's a lot of evidence that one of the big things we're seeing is that that's important is that more of, even though the overall average amount of rainfall hasn't changed much, more of the rainfall is occurring as heavy rainfall events. And so that a higher fraction occurs in those wettest days. And Oklahoma City is actually a pretty good example of that. Our summertime probability of rain hasn't changed at all. It's somewhere a little over 20% of the days it rains. But now the fraction of those days that we get 1 inch of rain if it rains has doubled in the last 30 years. It used to be about 1 out of every 7 days that it rains. It's now 2 out of every 7 days that it rains. We get 1 inch of rain. Overall, it doesn't change the total amount of rain very much. It's gone up a little bit, but 1 inch of rain in Oklahoma City is where we start getting nuisance street flooding. So it's a noticeable thing that we start having those kinds of events occurring more often. And if we go to the northern part of the U.S., that's even been a bigger deal. That a higher fraction of the rain occurs when it's really raining hard, and that means water runs off. It may recharge reservoirs, but it's not as good for say farmers as if there'd been a lot more slow rain events.
Yeah, we get fast, heavy and fast, and then it moves on, and we've seen that. So I love doing this because I get to ask the foremost experts my questions that I have over coffee with friends. So this is great, and hopefully it answers some questions for some others, if not just my friends. I want to ask you, these changes or the warming over long term, is it something everyone should be concerned about?
I think the answer is definitely yes. On a global scale, probably in some sense, the biggest concern is sea level rise. Sea level has gone up, and it's going up quicker than it was, and it will go up. The last time this much carbon dioxide was in the atmosphere was many hundreds of thousands of years ago, and sea level was roughly 100 feet higher than it is now. And eventually we come into equilibrium. It takes a long time to melt the ice on Greenland and Antarctica. I mean, that just it just doesn't go away very quickly. But we're sort of committed to melting a large part of Greenland and probably some of Antarctica. And the sea level is going to go up. I mean, that's just, and we're still talking about, you think about a place like, Florida, and very little of it is above 20 feet above sea level. And in New Orleans, it's just, hard to see how New Orleans 100 years from now will be there in the way that it is.
Just 100 years from now?
If we get a couple of feet more of sea level rise, I mean, even a couple of feet makes it hard you start having flooding happening all the time. And it becomes, maybe you can protect on that. It may take, 200 years, but we're sort of committed to large sea level rise already. For us here in Oklahoma, one of the real big challenges is that there's growing body of evidence that what geographers have referred to as the 100th meridian, which is not exactly on the 100th meridian, but it's a boundary that was noticed in the 19th century between relatively wet and dry regions that runs close to the 100th meridian from Oklahoma through in Nebraska into the Dakotas.
Okay.
There's evidence that that's moving east from a lot of different sources. And that would imply that we should expect probably by the end of the century, Western Oklahoma will be drier. Probably Central Oklahoma will be drier than it is now on average. And we already have lots of water issues in the state. Availability of water is a big deal in Oklahoma. That's going to get to be a bigger deal in the future.
Wow.
And how we adapt to that, how we attempt to mitigate as much of it as we can is a huge challenge. Those are all, water resources. The western part of the United States, almost everything about development is tied to water availability, and that's going to get to be more of a problem if things dry out on average. And we're going to be near a place that probably a lot of that change is happening. One of the things about Oklahoma is if you go to the eastern part of Oklahoma, you look at the trees.
Right.
They're radically different than the trees in western Oklahoma. We're right on that boundary between pretty wet and dry, and the tall grass prairie versus the short grass prairie. We can actually tell how this feature has been for thousands of years because of the different pollen records in different places. So we have long-term observations of where this line has been, and it's probably going to be as far east as it's ever been by the end of the century.
Wow. What say you, Mr. McManus, on this topic?
I actually grew up along the 100th meridian up in Buffalo, Oklahoma. And, if we look at the change just in the normals that the federal agencies track. So for the 1981 through 2010 period, the normal rainfall amount in Buffalo was a little over 24 inches. When we switched to the 1991 to 2020 period, that normal rainfall had dropped to 22 inches. So the semi-arid areas of, what we would consider West Texas, the Texas Panhandle, the Oklahoma Panhandle, that has started to shift east, like Dr. Brooks said. For Oklahoma, we don't have to go out too much farther into the future. When we look at the changes that are happening gradually, we will start to see more impacts. Now, for Oklahoma, like I said, one of the places in the world that has some of the most extreme weather on the earth with the winter weather, the blizzards. Mm-hmm. We have intense thunderstorms, tornadoes, everything associated with severe weather. How does climate change impact that extreme weather? So our extremes, if they get more extreme, how do we handle that here in Oklahoma? That's one of the big problems that we're going to face here. But, just the small changes over time. We're a state where folks are moving from the rural areas into the urban areas. When we start to heat up those summer months, even year round, you're going to have more air pollution, and that's going to impact people's the health of people in those urban areas and around the state. So, food production. When we start to shift those arid areas to the east, what happens to the wheat belt of Oklahoma? What happens to the agricultural industry? We've started to see our wheat industry start to suffer from more freeze events because the wheat starts to germinate earlier, or it starts to come out of dormancy earlier leaving it more vulnerable to freeze events. And when it comes out of dormancy earlier, that leaves it, when we just have a normal freeze event that we would experience in March, that wheat is a little bit farther along than what it should be. So we've seen those things start to happen in Oklahoma. But again, when we start to see those extremes start to become more extreme, what does the state do? And in an area where the natural variability of the weather is already pretty damaging at times to the economy and to the citizens' well-being in Oklahoma, what do we do when those extremes start to become a little bit worse over time? So again, that's where the areas of science we really start to need to focus, not just out to the 100 years, but what do we do in the next decade, the next 20 years, when temperatures are expected to rise over the next few decades, 3 to 5 degrees Fahrenheit on an annual basis in Oklahoma. So, what do we do then?
Well, that was going to be my next question. Is it too late to do anything?
Well, in a sense, it sort of is, but it sort of isn't. So, when we get these molecules up in the atmosphere, the carbon dioxide tends to last for a long period of time. The concentrations tend to stay elevated for a long period of time. Like Dr. Brooks was saying, it takes a long time to come in at equilibrium. And, one of our big sinks, the ocean, is still trying to take up all this carbon dioxide. But the carbon dioxide in the atmosphere is still increasing. It will continue to increase. As those concentrations are elevated, the feedback effects start to kick in. So as we're losing that polar ice up in the northern hemisphere, we start to uncover the darker oceanic surface, the darker ocean surface. And so we start to absorb more of that sun's radiation instead of being reflected back to space from the ice. The ice is, of course, white. It's a good reflector of that sun's radiation. So we lose a lot of that energy back to space. But as we start to uncover that ocean surface, it absorbs the heat. It heats up the ocean. The ocean starts to melt more of the ice over time. So eventually, when we get to be over the next few decades, what's expected to be an ice-free Arctic, at least during the warm season up in that area of the Earth.
It's an exponential impact.
Right. The positive feedback starts to become a runaway train. And, in effect, the polar region has acted as sort of a refrigerator or an air conditioner for the Earth. It keeps some of that, at least a portion of that sun's radiation reflected back to space before it can start to be absorbed by the Earth's climate system or the Earth's surface, whether that be oceanic or land surfaces. So it does become a runaway train, positive feedback, and that's one of the things where it might be a little bit too late to stop that runaway train. Even if we start to curtail some of our emissions, that's one of the things that that points towards mitigation is going to be so important. We of course know that green energy and things of that nature could help, but a lot of the what I would say damage has already been done, unfortunately.
But I'd say it's in some sense it's never too late to do something.
Right.
I mean, I ran track and cross country in college. Well, I can't do that anymore, and my physical condition is not what it was when I was in college. That doesn't mean that exercising won't help me live a better life. It may not be as good as if I'd been consistent for the last large number of years. I'd probably be in better shape now. If I
know what you're talking about.
Right. I'd be in better shape now if I started exercising a lot, 30 years ago. But that doesn't mean that, there's no hope in starting to do something now. And it's the same kind of thing. I might, 10 years from now, I might have wished I had started a lot longer. I'd be better, but I'll still be better off if I start now than I would be if I just said, well, it's too late. No point in doing anything about it now. And it's the same thing with the more we can do. It's easier. The earlier we start, it's easier. If we had started being serious about this when, it was evident to the scientific community back 50 years ago that the planet was going to be warming, we'd be better off than if we started in 2000, and we would have been better off if we started in 2000 than if we start now. But we're certainly going to be better off if we start doing things now than if we wait 20 more years to do anything.
Well, listen, I want to thank you so much for your time.
Welcome.
It's really good information, and it's great to get it from experts like the both of you for the state of Oklahoma. We appreciate it very much. Good to know. Thank you both.
You're welcome. Have a good day.
You're welcome. Thank you.